All right, so part 2, we see very similar directions to the last one in terms of this is another one where we need to factor. And I like it the last one we did it was also a trinomial, but the key to this trinomial is something's got to be funny because those don't match up. This is like trying to factor with x squared and y. It just can't happen. So we're going to have to do think a little bit outside the box and think, well, we have all these identities, and the one of the Pythagorean identities, 1 plus cotangent squared theta is equal to cosecant squared theta. So I could actually make a substitution. I could actually take out the cosecant squared. I could take this part out. I could replace it with 1 plus cotangent theta. So that's what's going to happen. This is going to be replaced with 1 plus cotangent squared theta minus cotangent theta minus 3. And I say, okay, now I have some like terms. I have 1 and negative 3, so I could write this as cotangent squared theta minus cotangent theta. That would be minus 2. This looks like it could be factorable. It's a trinomial. Now they match up like the last one. Instead of writing x here and x here, it's going to be cotangent theta and cotangent theta. And we'd be looking to say minus 2 and plus 1. That's, you can check it. It's factored correctly. You would be completely done. So this idea of factoring with some trinomials, it's no different than factoring with variables. It's just, it looks a little different. But if you can factor with an x, you can factor with a tangent x or a cotangent x or any of the above. All right, so again, we're looking simplify. Another word for simplify is factor, similar directions. Okay, so right off the bat, it doesn't look like there's no GCF. There's no difference of squares, so that's the only two ways I know to simplify. So I would need to be thinking, could I use any of my identities? Well, I can't change sine t. I'm going to keep that as is. I do know one for cotangent. Cotangent has a reciprocal identity. That would be cosine t over sine t. That's the definition for cotangent t. All right, the definition for cotangent is a reciprocal identity, cosine over sine, so times cosine t. So now I start to see, okay, I could simplify this. I could call that cosine squared. So I have sine t plus cosine squared t all divided by sine t. So still trying to further simplify. Well, now I have this fraction on the right-hand side over here. And I'm not going to say every time, but one of the strategies you'll see that if you see a fraction, one of the possibilities is to try to get common denominators and add them. And I can easily get a common denominator here, because if I multiply this by sine over sine, well, now the top, sine t times sine t, is sine squared t over sine, plus the cosine squared t over sine t. Well, now, the top, I hope you realize that when I write this over the same denominator, sine t, well, the top is sine squared t plus cosine squared t, and I hope you know what the top is equal to. Your Pythagorean identities, which I said many times today, are going to be extremely important. That whole sine squared plus cosine squared, all of this is equal to 1, and 1 over sine is the same as cosecant t. If you ever get, sometimes I don't like working with t as a variable, you're welcome to change. If you want to always work with theta or always work with x or u, whatever you like, you're more than welcome. Okay. Again, here is just, so here we're asked to substitute x equals 2 tangent theta. They give us the fact that we know it is in quadrant 1. They want us to replace x with 2 tangent theta. So we can write this as a trig function. So if I start this square root 4 plus, instead of writing x, they want us to replace x with 2 tangent theta. So 2 tangent theta, this whole piece is squared. That means the 2 is squared and the tangent is squared. So if I do that, it's still the square root 4 plus 2 squared and tangent squared. That's 2 squared is 4, tangent squared theta. Great. Well, I can factor, so now it's like, well, how can I simplify? So now that I've substituted, how can I simplify? And I see, all right, there's 2 terms. You could factor it. There's not a, there's something in common, so I at least have a GCF. There's a 4 in common, leaving me with 1 plus tangent squared theta. And I hope you're recognizing from your Pythagorean identities, which I did say were extremely important. 1 plus tangent squared theta is equal to secant squared theta, so I could make the substitution. I could leave the 4 right where it is, replace the 1 plus tangent squared theta with secant squared theta, and now this simplifies down because I know the square root of 4. Square root of 4 is 2. I also know the square root of secant squared. That's just going to be secant. Now I have a complete answer. So I do understand this section is extremely challenging. The next 2 sections are not easy. It takes dedication. It's like a puzzle. You don't look at a puzzle and immediately know where all the pieces go. And that's what's going to happen on these problems. You have to look at them enough, and eventually you start to see some patterns. Use some strategies like adding the fractions. When they're get common denominators and add fractions. Look to factor is one of the important pieces from today, and then getting comfortable using the identities and using substitution to play around and change pieces in and out. As you get better, you have a better idea of what pieces you need to change in and out. So my advice is to stick with it, and we will practice more in class. See you then.